Hello there, Vincent from VMware here, and today I'm going to do more demos. Right, I'm going to focus on NSXT for Kubernetes demos. So it's going to be a comprehensive list or exhaustive list of 10 demos, incorporating some of the VMware tools like vRLI Network Insight, Log Insight, vROPS, and as well as Wavefront. So um, I've been doing some of these demos, NSXT for Kubernetes, PKS, over the last few weeks with customers. Um, if you look at the list of VMware tools here and the integration of work, there's a lot of work, and so I thought, why not I record it, show it to the wider audience, the community, so that hopefully you'll find it useful. Okay, so basically I will cover on a quick introduction on NSXT for Kubernetes, then I'll jump straight into the demo. So in NSXT data center, we have this new use case basically to support the cloud native um, platforms, uh, cloud native apps platform. So whether is it for Kubernetes, PKS, PAS, or even OpenShift, we have this common NSX platform to support these various container as a service or platform as a service. Right? So in NSXT, we provide this NCP plugin for Kubernetes. So basically, when we launch PKS, we already have the support for Kubernetes, right? Um, we have been long supporting OpenShift. Because OpenShift is most of the customers today are using it for Kubernetes, and since we support native Kubernetes, right, the plugin can be used for Red Hat OpenShift here. The difference among this platform is PKS. Once you put in Ops Manager in the tile, the integration with NSXT is done for you, right? So the installation of NCP is done for you. Whereas Kubernetes, native Kubernetes or OpenShift, you can actually put it as part of your provisioning of your Kubernetes cluster process. Okay. So NSXT is basically the best in class networking for your Kubernetes cluster. Right? It provides network virtualization and automation for Kubernetes. So when the developer is using kubectl to create the namespace, for example, the T1 router will be get created in NSX, right? Or whether there is an ingress for your applications, you get to see that in the load balancer as well. So things like this, right? So it provides a complete layer 2 to layer 7 networking services for your cloud native applications, right? So switching, routing, load balancing, firewalling, as well as a layer 7 load balancer. Okay, so like microsegmentation that you can do for VMs, right? You can do that now with port to port. So if you want to do uh, microsegmentation for ports, you can do that with NSX-T. Okay, so many times I'm being asked, right? So what's the difference between NSX-T to some of the open source networking options? So if you look at, let me load all the slides here. So if you look at some of the open source solutions like Flannel, Calico, they solve specific networking problems, right? So like Flannel solve layer 2 networking issues, provide layer 2 networking only. So if you want layer 3 networking, you have to get Calico, right? So if you want to use IP tables, you have to use Calico. And some of the um, container as a service solutions comes by default with some of these open source solutions, right? And it's also um, particular. It only provides capability to that particular container as a service solutions. And then if you most of the container as a service requires load balancing, so you require to create your own Nginx or HAProxy to for load balancing requirements, right? So the difference here with NSXT, it provides all this layer 2, layer 3, layer 4 load balancing capabilities for your cloud native applications. So it's one solution for all your networking requirements. So it doesn't require a different solution for different container platform service, right? So if you look at the tools that NSXT provides, it's comprehensive, right? So we have like port mirroring, IPFIX, trace flow tools. So you know, when I spoke to some of the customers, some of the open source solutions that they use, yeah, it works on day one. When it comes to troubleshooting on day two, you know, it's like a black box to them. They don't know, they don't have the tools to troubleshoot, right? So NSXT, you know, pick up the gaps, right? So it provides the tools for you to do troubleshooting, monitoring of the port networking, right? And it supports multiple platforms as a container as a service, so you don't have multiple different solutions, right? Okay, so coming to my lab topology, so I'm using PKS in my lab for this demo. Okay, so basically, right, you have this management network which runs the PKS control plane, Bosch Ops Manager, and all this. So this sits together with my vCenter and my jump host. So most of the demos will be running from the jump host over here. So this is on you know, a VLAN network, right? So the overlay networking is provided by NSXT. Um, so you have multiple T1 routers. So every namespace will consume a logical switch as well as the T1 router. So some of these are the defaults logical switches, right? The nodes will consume so the worker nodes and the master nodes will consume IP address from these, which is called node networking, right? So you can give them a IP block, and they will consume, every clusters will consume a /24 from this block, right? For the port networking, right, it's also an IP block that you specify in NSXT, right? So every time when you create a namespace, right? So IP subnet will be taken from this IP block, right? 172.31/16. So I also have a floating networks or floating IP pool. That's where it's being used when SNet, SourceNet is being used, or a load balancer virtual IP is required, right? So they will take the IP address from this pool. So all this are configured in NSXT, and you know, you can check, you can go into the NSX manager and take a look at all this network configuration. Okay, so this is the demo list. I have 10 demos that I have prepared to show. Will not run through one by one, but basically mostly are NSXT related. So before I begin to the demo, right, you know, one thing here, it's, or when I'm doing this, because there's only one jump host, you know, sometimes my customers' feedback is quite confusing. So what I'm trying to do here is I will tell you, you know, I'm playing a role of a developer, I'm a network engineer when I'm trying to do, right, I try my best to inform you the role that I'm in while doing that command. Okay, so all right, demo time. So this is the jump host that I'll be using for most of my demos. So if you've seen over here, this is a PKS cluster. So this is usually done by the platform team, if you have one, or the virtualization guys when they create the clusters. So once they create a cluster, they will hand it off over to the developer, right? So you need to get credentials here. Yeah, right. So once this is done, you know, you will download the config, over here. So this one can be passed to the developers, right? So once that they load it into their, their laptops or whatever, okay, they can um, look at the cluster information. Okay, so so basically they can get to like a namespace. Okay, uh, so I have this Yelp app that I'll be using for my demo, which I'm going to show you. Okay, so this is the so it's basically a multi-tier application, and so it comprises of Redis server, web app, DB, right? So the things to note here, it has this service which is a load balancer type service. Basically, in NSX it will be using a layer 4 load balancer in NSXT, okay? And basically you will load balance the Yelp UI, right? So if you look at here, there's replica of two of these Yelp UI. This is the web server, right, on port 8080. Okay, so once I do this, when I load this, I'll get to show you the load balancer has been created. Okay, so before I do that, let me create the namespace. So if I were to use this create namespace like this, by default, it will be SNet. The ports, when you communicate with the physical network, it will be SNet. So that's not what I wanted. I want it to be routable. So in that case, I will use this YAML file instead. So let me show it to you. So you have to specify this annotation where it says no SNet. So what it does, when this namespace is created, there will be no SNet configuration, and therefore when the ports communicate out, you'll be using the native IP address of the port, right? So I will show it to you on the second demo, but in this demo I will show you the layer 4 load balancer. Okay, so let me create this namespace. Okay, and let me change the context over here, right? So sorry, okay, let me see, set config. Yep, so I'll set a config to cluster to 03 and namespace. Yep, okay, good. Doesn't save me from typing cluster. So now I will create the application. Okay, so let me see. Containers. All right, it's all running. It's pretty fast. Okay, so let me see what's the virtual IP. So this is the virtual IP over here, 10.20.0.113. So if I were to go to here and okay, let me close this, right? Create a new one. All right. You get to see, okay, well, so basically this is a restaurant app. You can vote for your favorite restaurant, right? So it's working. Okay, so if you go into NSX over here under load balancer, okay, you get to see these virtual IP over here, right? Over here, right? So this is being created when you type in a service type load balancer, right? So you click on this, you can see overview, right? So this is the virtual IP, right? So this is the virtual server, virtual IP, and it's a layer 4 load balancer. So you go into the server pool, and this one, you get to see the server pool and the pool members, right? The exact IP address of the ports. So you can tell you over here. So basically it's this two, right? 49.2 and 49.4, which is over here, right? That's good. So this is showing you, it's being, the load balancer is being processed by NSXT. Okay. So the second demo here is I'm going to show you that any traffic coming out egressing from the ports is going to be using its own native IP address. Okay, so let me log in to the ports. Okay, so I'll log into .2, which is much easier. Okay, so I'm in the container itself. I can use, you can see that this is the IP address. Okay, so I'm going to ping the jump host. So the jump host is 192.168.110, right? So it has connectivity, right? I want to see what's the source address, so I'm going to use Wireshark over here, right? Okay, so I'm going to apply a filter just to, so that you can see the traffic. So there you go. You can see that it's ICMP, and the source IP address is coming from 3149.2, right, which is the IP address of the ports. Okay, so what's this is useful, right? For example, you have different apps and you want to control the access to a physical database or a database VM, right? So now you can actually use the exact IP address of the ports to do access control, right? But whereas in the case of SNet, it might be netted to the same IP address. You might not be able to differentiate app 1 to app 2, right? Hopefully that makes sense to you. Okay, so the next demo is going to be a service type ingress. So ingress build. So basically there's you can specify a wildcard domain over here. So let me show it to you, right? So this is the domain I'm going to use, right? You can specify the wildcard domain. So every time when you create the clusters, there will be a virtual server of being provided, and you can specify your developer can actually specify what URL they want, right? So let me show it to you. So over here in NSXT, so this is like the network guy created, using it to show it to you. Okay, so if you look over here, so this is the one, right? 10.20.0.98. So this is the one that when you create the clusters, when you want to use layer 7 load balancer, you get to see what are the URL that developer has been used, and you will get to see when the developer used a layer 7 load balancer. Okay, so so now I'm like the developer right now. Okay, let me log out. Okay, and I want to have an ingress, so I want to specify my own URL over here, right? So if you see over here, I'm specifying this URL to be used for my application, my YAP application. Okay, so let me apply YAP Ingress 2, right? So you can see that this ingress is created. Okay, so I can get to see ingress, right? So you can see that it's associated to this IP address, which is the load balancer. So I take this URL and I go over here. So previously I was using the IP address, now it's the URL, right? So that's 4, so you should be showing the same thing. Okay, so let me go back to the NSX now and let me do a refresh. So the network guy can actually see, what's the URL that the developer has used. Okay, so that's the demo, which is showing you the Kubernetes ingress. The next thing, it's about security, right? So there's two models that you can do over here. So one, it's a predefined security model where the security or the firewall engineer will create the firewall rules, and the developers will use labels in his YAML manifest to specify, what is this application belongs to, which group it belongs to, and or and NSXT will pick up the labels and place them into the respective groups, right? So when so in my manifest, I already have done that. So let me show it to you. So if you look over here at the label, yep, there we go. So this is the UI, and I put it with a label set group web. Okay, and this is the cache, this is the DB, and the app. Okay, so the labels are already done. So in NSX, what I do is, I can create a predefined policies, right? So before the app's being pushed or apps is really pushed, I just want to write the policies for it. So I'm going to show you microsegmentation over here. Okay, so first thing, I'm going to create the groups. I'm going to show you the web. So I'm going to create a web, right? And I'm going to match the criteria. So the tag is going to be matching of web, and the scope is group. Okay, so once it's done, you click on that. You get to see, the logical port that's associated, right? You also get to see the IP address, right, which is the web. So let me see. Hang on a minute. There you go. Right, there's two. Great. So now I can make use of this group in my distributed firewall rules. Okay, so I have pre-created this admin section over here. So I'm going to put my rules over here. Okay, so I click on this. I'm going to add a rule. Okay, and basically this is like web, right? And then you can specify the source. Okay, so I created a group that I just created. Okay, and the destination is going to be web. Okay, so I will lock it, and then I'll leave it as allowed first. Okay, so let me log into excuse me. Hang on a minute. Hit log inside. Okay, so let me log into the same web server. So this is the .2, right? I got to do a continuous ping to 49.4. Okay, so you see that there's actually layer 2 connectivity between all the ports, right? They are on the same network. So like what you have, like microsegmentation for VMs on the same network, you can actually block them. That's what I'm going to do, right? So so before I do that, let me show you some logs first, right? So I can put ICMP. Let me see whether I can get to find the logs that show you. Interesting. Just hang on a minute. Okay, ICMP. All right, there you go. See, so you can see that 49.2 is trying to ping 49 and match pass. All right. Okay, so now I'm going to leave the ping continue. I'm going to change my file policy to show that you can actually do microsegmentation, right? So I'm going to change this rule to drop, publish. Right, you should be able to see the ping has dropped, right? So sequence stop, and I'm going to show you the logs. But before I do that, I need to restart the ping so you can see that it doesn't go through. Right? So you go to the logs again, try to create. You can see that it's dropped, right? So you get logs for your ports, so you can start logging for your ports communications if you want to, right? If you just want visibility from distributed firewall logs, you can do that. All right, so that's the first model, right? I'm going to show you the second model, which is basically using the network policies from Kubernetes. Okay, let's just before I do that, let me change back. Okay, allow that. Right, you can see that it continues. The ping continues. Okay, cool. Okay, so the next thing I'm going to show you is the network policy, right? So there's demo 5 here. So okay, so basically, the developers can write the ingress, and then NSXT will take this ingress part and translate into distributed firewall rules. Okay, so basically you specify the web port is 80 and the app server is using 4567 and the DB should be 5432. All right, so I'm going to apply the policy. Okay, so from here, right, because I've created a section, right, I've named the section over here, so I can show you over here, right, manage text. So this is the bottom, right, that's the top over here. Okay, and I need to refresh. You can see that the policies that the network policies, the Kubernetes network policies, will translate into rules. Okay, so you can see over here, let me expand for you to see. Sorry, give me a minute. There you go. So just to show you some of this, so basically you click on it, right? You can see the IP address. So source is coming from basically this is the web UI, right? So the web UI going to I believe it's the app, right? So let's take a look. .6 is it the app? Yep, .6. Yep, it's the app. Okay. So you get to see all these policies over here. So by default, the policy is really just give me a minute. Right. So this is the policies over here. Okay. So if you can see by default, the any traffic from the port, like anything coming to the port is block. Okay, then access from the ports by default is allowed. All right. So these are the policies that has been created. Okay, so going to the next section, which is mostly on the visibility and tools portion, right? Let's make use of trace flow, right? So for example, there's some problem with the app, and app doesn't work. Let's take a look at you can take a look at the flow, right? So this is making use of the overlay capabilities in NSX. So right now I want to see, for example, the ports, app, right? You can see the actual IP address, and let's see to the database, for example. Right, you can see the actual IP address. So if you do trace flow, right, you get a trace. So you get to trace the flow, communication flow between two ports. Okay, and you see that it's being dropped. So distributed firewall is doing its job, right? So from here you can click on the diagram. So this is basically the worker nodes. So I only have one worker nodes, right? Okay, and these are the logical ports, right? And this is the host itself, right? where the worker node is running. Okay, so since I know that the database port, I believe is 5432, is allowed, let me redo the trace. Right, this time around, I'm going to put in some advanced settings. Destination 5432. Start tracing. And you can see that, yep, this time around is successful, right? So you get to see the actual rule ID that is being allowed or passed through. Okay, so do you have trace flow? Okay, so let's say for example, that still doesn't solve the problem. The network team trying to help, and network guys are familiar with Wireshark, and I want to use Wireshark. So, when it comes to physical switches, you can do a port mirroring very easily on the physical switch port, right? Just connect a laptop with Wireshark running. But of course, the configuration on the physical switch might not be that simple. Like you have to go to the actual switch, or you have to use if there's a local span, if there's a remote span, you have to configure your network to do that as well. But when it comes to ports or containers running in a VM, things get a little bit tricky, right? So the cool thing about NSXT, we provide port mirroring, whether is it on a virtual switch where your VMs utilize, or the ports, right? The Kubernetes ports sits on, right? So I'm going to create a remote layer 3 span. Okay, and I'm going to span it to the same jump host, right? So the remote span allows you to span virtual machines. Okay, so that's what I'm not going to do. I'm going to span the whole logical switch, right? So so how do I know the switch? Because I know the PKS cluster ID, and I know that every clusters will have a switch, right? So let me do like Yelp, right? And okay, let me find the exact one. This is the one. So this is the one that is my cluster ID. I'm gonna select, and that's where all the ports is gonna reside on. Okay, and I'm going to make sure that the span goes to the jump host. Okay, so for example, if I were to on Wireshark now, I will get to see very very busy traffic, right? So maybe I will not want to do that. I want to be more specific. Maybe I want to know, like, okay, what is communicating to my app server, and I know that my app server is running on 4567. Okay, so let me do that, and let me start running. So there's no traffic going to my web server, or my app server, sorry. And let me try to reload. There you go. So you can see that the app server, it's talking to the UI, web UI, which is .4, right? So you can see from here, right? So let me do another refresh. Right now you get to see like .2 because the load balancer is working, right? Because the load balancer is load balancing between .2 and .4, which is the web UI, and they're communicating with the app server. Okay, so you can, the network engineer can make use of a Wireshark tools to understand, to troubleshoot, or to understand the traffic flow of the applications running in the Kubernetes pods. All right, so if you think about monitoring, right? So we have vRLI network insight. Basically, it's a NetFlow IPFIX collector, and in NSXT, we also provide IPFIX where you can export the flow, right? So I already configured exporting flow to the vRNI. So I have vRNI over here. Okay, so I'm going to log into vRNI. Okay, and I would like to maybe understand the flow, right? So I can type flow here, right? And I can take a look at so basically it's VMs and containers. So since I know the destination port, I can use the destination port if I want to, right? Or I can use IP address if I want to as well, right? Destination IP. Okay, so this time around I'm just going to use ports. So same thing like the port mirroring. I may be interested in the application port, right? So if I can put over here and I will just go scroll down to 5432, right? You can get to see now communication. So from here you can see that this is basically the app server talking to, I don't know what's .5 it's the DB, right? So app server is talking to the DB, and on 5432 which is the database port. So the app port is actually, sorry, let me see what's the port. I believe it's 4567. So this is the communication to the app server, right? So you can see this is the web talking to the app, right? So and then you have yeah, so you have the let me see over here. So .3, what's .3? So you have the cache talking to the database as well, right? Is it? No, talking to the apps, to the web server. So the web server, so the cache is replying to the web server, right? So you can get to understand the traffic flow, right, in vRNI. So pretty good to look at the container or ports to ports network traffic in your data center. All right, so that's about it for NSXT. So just to sum it up, you have multiple tools that you can use in NSX over here: trace flow, port mirroring, IPFIX, which is very handy when it comes to troubleshooting, right? Okay, so additional to vRealize login side, in vROPS there is also an adapter for Kubernetes. So right here you can see that it's showing some metrics over here. So I only have one node in my clusters, and I created additional namespace, right, and showing you some of the ports and number of containers that's running, right? So showing some of the health of your clusters over here. So it's a good monitoring tool for your Kubernetes clusters, right? So that's number 9 demo. And last but not least, I just want to show you Wavefront, right? So this is the integration with PKS over here, right? So this Wavefront is a SaaS service. So we give you tons of metrics showing you the health of your Kubernetes clusters, your PKS clusters. So you can see that the numbers actually tallies with vROPS. That's a good thing. You get to see the memory usage, CPU utilization. You get to see your nodes, right? It plots you the charts, really nice. And so you can get to see over here, get to see the nodes, right? There's lots of information. You can get to see the namespaces, right? So you post namespaces over here, okay, and you can see your ports, right? Lots of information here, right? So I'll definitely worth your time to take a look at Wavefront providing metrics for your uh, Kubernetes clusters. All right, so um, thank you for staying the end of the demo, right? So this is the last demo that I'm going to show this Wavefront over here. So hopefully you get to see some of the integration between Kubernetes and NSX-T, right? And let me know you would like to see more demos. Just contact me via LinkedIn or Twitter, and I'll be able to create more demos. If not, thank you for watching this video, and see you next time.